All right, so yesterday we plotted these guys, right? Right? And then we drew line of, or we didn't draw line of best fit yet, did we? We only talked about, what was that big word we talked about? Starts with a C. Correlation, yeah, we talked about correlation. Okay? If my data is rising, my correlation is positive. If my trend line is falling, my correlation is negative. And if my points are all over the place, splattered, what do we call it? No correlation. Okay? On your worksheet yesterday, did you get any no correlations? No. You should have gotten all positive or negative. All right, so today we are going to talk about how to draw line of best fit and how to find the equation. I know. So in your notes, right, yep, same thing. 0 and no would be the same thing. Yeah, either way. Either way is fine. But you got a 0 correlation? You shouldn't have. Yeah, it should be negative. No, wait, 7 should be positive, yep. Yep. Yeah, it's kind of, it's a little, it's not as, no, it's more scattered. It's not as tight as you would necessarily like it, but it still definitely rises. Okay? So yesterday we plotted these points, right? We had age down here. We had body length over here. This was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What did we go up by on the side? 5s? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, so it was 1 and 8, 2, I'm going to do this quick, 3, 15.5, 4, 16.7, 5 is 20.1, 6 is 22, skip 7, 8 is 26.5, 9 is 29. All right, so you're going to need some blank space over on that side because there are about 6 steps that we are going to, that involve what we are about to do. Okay? So, first step is plot your points. Did that yesterday, right? Boom, done. Yeah, I would just put it on that blank page, yep, beside this one. All right, so step 2 is draw a line through the middle of the points. Okay, so this does not mean we are playing dot to dot. Okay, we're not going to have this big jagged line by connecting all the dots. What we are going to do is we are going to draw a straight line that goes through the middle of these points. Okay, so I'm just going to start from right here, and I'm going to try to get through the middle of most of that data. Okay. It needs to be straight. Okay, I mean, not like you need to get a ruler out and make it exactly perfect straight, but it needs to be close. All right. Are we good? Step 3. Yes, it needs to go straight. And I'm not talking like you need to put a ruler down and make it like perfect straight, but it needs to be pretty close to straight. Straight through the middle of the points. No, we don't. It can't curve. It has to be a straight line. If the point's curved, that's fine. Okay, the line that you draw has to be straight. Okay, no curvies. Straight line.
So you can't go from...
No. No. Straight line. All right, step 3. Okay, we are going to choose 2 points that are on my line, or on your line. Okay, so here's the deal. They do not necessarily have to be points that were in the table. Okay, I could choose, if I wanted to, I could choose this point right here. Because it's on the line, it's not one of these plotted points, right? But it's on the line, right? I can choose any points that are on the line, or that the line goes through. Does that make sense, what I'm saying? That they don't have to be one of these black points. I could go through, because there's imaginary points all along this line, right? And I could pick any 2 points that are on that line. Does that make sense? All right, so let's choose 2 points that are on here. I'm going to go with this guy right here, because I like perfect, yeah, there you go, like perfect numbers that like have like where I know like they're the exact numbers. So like this guy right here goes through right here, right?
Wait, it doesn't have to be a point on like the one or...
Right, that's what I said like 18 times. Okay. All right, so this one is 315. So I'm going to put down 315. So there's 1 point, right? And I need another point. I want another point that is fairly perfect, which I see one about right here. Which is, I don't have 830. I have 930. I'm doing 9 and 30. What's up? We're picking 2 points that are on my line. They don't have to be the black points that were in the table. I'm just picking 2 points that are on my line. Right now, all I'm doing is picking 2 points. They don't do anything yet. Well, we're not there yet. Right now, I'm picking 2 points that are on my line. We'll know what to do with them when we talk about the next step. Okay, right now my step is just picking 2 points. All right, so we have our 2 points. Step 4. We're on step 4. Not 5. Step 4 is find the slope. Does anybody remember the formula to find slope when you have 2 points? No, that's slope-intercept form. You're close, but how do you find that m? Okay, but if I have 2 points and I don't know my rise and my run, yeah, no. All right, y2 minus y1 divided by x2 minus x1. Give you guys a chance to write that down. Everybody got it down? All right, so if we look at my 2 points, okay, we can label them x1, y1, x2, y2. All right, so if I'm plugging it in, y2 is 30 minus y1 is 15 divided by 9 minus 3. So on top we get 15. On the bottom we get 6. Now here's the deal. We're going to go decimals to 2 decimal places. Yes, ma'am. Or yes, sir. Sorry.
For finals, do we take anything about last semester or only this semester?
This semester, but let's worry about this right now. We'll talk about finals when we get a little bit closer. Yes, ma'am.
Never mind,
All right. 2.5 exactly?
Yes.
All right. Ooh, so my slope is 2.5. All right. Step 5. Use your x1, y1, whatever point that was, and your slope to put into point slope form. Who remembers what point slope form was? No, y equals mx plus b is slope intercept.
Is it, that really long one?
Uh-huh.
Is it like
Y minus y1 equals m times x minus x1. Why you no write that down?
Yeah, we'll sit down and just think of the problem.
Yeah.
I don't know. He's actually got a point. Did you have a question, Mr. Christian?
How are we going to remember that?
Well, it's from last semester. We spent about 2 months on it. Well, then you better write it down and start studying it. Just how you remember everything else. All right, so we're writing this equation. So we've got y minus, what's my y1? 15 equals m, which is? Yep, exactly. If you used different points, you're going to get a little bit different equation, and that's okay. And then x minus x1 is 3, yep.
Wait, so we're not going to really be checking it?
Kind of, because you're going to be close. Yes, your stuff will be close. Just relax. We'll talk about it here in a second. First, let's get through this. Okay? And step 6. Yep, solve for who? That's not how you spell solve. Solve for y. Oh, man, I am struggling. Solve for y so that when we end up doing it, we're going to get y equals mx plus b when we solve for y. So when I'm solving for y, okay, what's my first step? No. Not plus 15. Distribute. Y minus 15 equals 2.5x minus what? Minus 7.5. And then we will add our 15. So y equals 2.5x plus 7.5, yep. All right, so let's talk about what all this means. Okay, basically when I find the line of best fit, I'm finding the averages of what was in my table. Okay, so this guy right here on the end stands for what? My B, which is my y-intercept, which would be my at age what is my starting point? 0. So basically my starting point, this is saying when my panda is born, on average, he's going to be how long? 7.5 inches. Okay? And then that 2.5 is my slope. What does that mean? Yeah, it means this is my rate of change. This means that each year, on average, he's growing about 2.5 inches every year. Okay? Does that make sense? All right. So flip to your assignment. Go to number 1. Yep. I would have your steps out, yes. Oh, yeah, we didn't talk about that. Okay? Yeah, if I'm trying to find 7-year-old or 7-month-old panda, I've got my equation. Y equals, bless you, 2.5x plus 7.5. To find 7-month-old panda, plug it in for x. So we would have y equals 2.5 times 7 plus 7.5. So y equals, what's your 2.5 times 7? Guys, we're still doing this one. You're going to need to know how to do this in order to do your worksheet. What? 17.5 plus, what? 7 times 2.5? Okay. Plus 7.5 is 20 to 25 even? All right. So at 7 months old, this panda would be 25 inches. Okay. So let's talk about, would this be linear extrapolation or linear interpolation? Okay. Just listen. Well, but some people aren't listening. Some people are doing their assignment still when they need to be watching up here. Okay. This is interpolation because if you look at our graph, 7 is inside my set of data. Okay, so it's in the inner part of my set of data. Okay, so inner interpolation. Okay, if it's in the inner part of my data, because 7's right here on the inner part, then it's interpolation. Yep. Okay, so let's say we wanted to find 1.5 old panda. How many months is 1.5? 18 months. So let's say we want to find 18-month panda. We still have y equals 2.5x plus 7.5. What am I plugging in for x this time? 18. So y equals 2.5 times L times 18. Would be 45 plus 7.5. This panda would be about 52.5 inches. Now, is this inside my set of data? No, it's on the outside of my data. So we would call that extrapolation because it's an extra point off my graph. Does that make sense? When it's inside the graph, would be like on the graph. Okay, when it's outside the graph, it's extrapolation. Outside the graph. Yes, ma'am?
So, if the graph, like the sum still goes up to 50, but your line isn't up there, if it's plotted at 50, it's in...
No. No. If it's off the graph, off my set of data, okay, so like if it's not within, so my set of data went within 1 and 9, right? Okay, so anything outside of that 9 would be extrapolation. Okay, make sense? All right, go to work.